Today, we're going to walk through the blood clotting process, which is crucial for stopping bleeding when you get injured. It's a complex, multi-step process, but let's break it down into two main pathways, the extrinsic pathway and the intrinsic pathway, and then we'll finish with the formation of the clot itself. Extrinsic pathway process. Step 1. Tissue damage. When a blood vessel is injured, the tissue around the wound is damaged. This triggers the extrinsic pathway. Step 2. Endothelial cells. The endothelial cells lining the blood vessels release substances in response to the injury. Step 3. Tissue factor, thromboplastin. One key substance released is tissue factor, also called thromboplastin. It's the main initiator of the extrinsic pathway. Step 4. Calcium ions, K2+. Tissue factor combines with calcium ions, K2+, and activates clotting factors in the blood. Step 5. Clotting factors. These clotting factors work together to form a complex called prothrombin activator, which will lead to the creation of thrombin in the next step. Intrinsic pathway process, platelets. Step 6. Platelet activation. Within the intrinsic pathway, platelets are activated by the damage to the vessel wall. Step 7. Hegeman factor, factor 12. The Hegeman factor, factor 12, is activated in the bloodstream and begins a cascade of clotting factors. Step 8. Platelet stick. This cascade makes platelets sticky, allowing them to adhere to the exposed collagen in the damaged blood vessel. Step 9. Positive feedback. Once platelets start sticking, they release serotonin, a chemical that causes vascular spasm. This tightens the blood vessels to reduce blood flow. This is a positive feedback loop, meaning more platelets keep coming to the site. The clotting cascade process. Step 10. Prothrombin. The prothrombin activator, from both the extrinsic and intrinsic pathways, activates prothrombin. Step 11. Prothrombin is converted into thrombin, a key enzyme in clot formation. Step 12. Fibrinogen to fibrin. Thrombin then activates fibrinogen, converting it into fibrin, a sticky protein that forms the structure of the clot. The final clot. Step 13. Fibrin. Clot. The fibrin threads weave through the platelets and red blood cells, forming a clot that seals the wound and stops the bleeding. And that's how your body stops the bleeding within 3 to 6 minutes through a carefully coordinated process of clotting.